First lesson in chapter 6 is completely review. It's just about finding the area under a curve. And as far as I'm concerned, there are basically two types of problems that we're going to work with here, and they both have to do with the bounds. In one of them, the first type, the bounds are going to be incredibly obvious, and in the second example, the bounds will be slightly less obvious. So I'm going to go to the next slide and just get right into the first one of these two review examples. So the first one I have is, we have the function here, y equals 1 over x, and I'm just asking us to find the area of the green region. So I'm hoping that you guys remember that in order to find the area of a region, what we really do is we just take the integral, I didn't want that to be green, we take the integral of the function that we're looking at with respect to x, and then I have to look at, as I sort of read this function from left to right, where does the region start and stop? And like I said, in some problems the bounds are given or they're really, really obvious. In cases like this where they actually sort of define, vertical lines on the left and right hand sides, it's really clear that these bounds are just intended to go between 2 and 4. As we get further into the chapter, that may become a little bit less obvious, that we'll get into more complicated problems. But for some problems, they're just going to sort of give you left and right bounds. You'll be able to see them, and it's pretty easy. So wonderful. We take our function, 1 over x, which is sort of defining the top of the region. We take our left and right bounds, set it up, and then from here, it's just a matter of integrating. Hopefully, you remember that the integral of 1 over x is the natural log of the absolute value of x, which we then evaluate from 2 to 4. And all that really means is that we plug in our top bound minus, we plug in our bottom bound. And we could stop there, or we could remember our properties of logarithms that tell us that when you've got something like this, you can divide the things that are inside, so the natural log of 4 over 2. And so the answer for that area is the natural log of 2. So again, really not a big deal. All it comes down to is when you need to find the area of a region that is bounded by a function and the x-axis, we just do the integral of the top function of the boundary on the bounds. So that was my first example of one where we have very obvious bounds, just a left and a right. The second example is a little less pretty, but I still kept it pretty nice. So it's less pretty because I couldn't do this one with a computer-generated graph, because if I did that, it would just give you the bounds really obviously like the last one did. Same question here. I want us to find the area of the green region below. It's bounded by the function y equals x squared minus 2x. But in this case, I don't know exactly what the bounds are. I mean, it seems pretty clear that the left one is 0. And if you have decent math, mental math skills at all, you can probably tell what the right bound is. But, just to kind of get us back into the swing of things, what we need to figure out is okay, so for this problem, sure, maybe it starts over here at 0, but where does it end over here? Because I don't have a computer-generated graph, because I'm not told what the left and right bounds are, I have to find them. And in this case, and this is the part you really need to hear, the bounds here are sort of found by where the function intersects the x-axis. In other words, where does y equals x squared minus 2x intersect the x-axis, which is y equals 0? And so what this really means is solve this system of equations. Right? And so this is very easy. We just, we'll plug 0 into here. We get 0 equals x squared minus 2x. We'll do a very easy factoring and get x times x minus 2. That means x is 0 or x is 2. And so that tells us, okay, great. So this thing started over here at 0. It's ending over here at 2. Great. And so that just means that we can now do the integral of our function, x squared minus 2x, between 0 and 2. And there's going to be a little bit of a snag here. I hope you guys remember it. So we'll finish the problem out and then we'll talk about what that snag is. This should be a very easy integral to do. I think it's worth pausing the video and running through it by yourself real quick just to make sure you could do the basic arithmetic of these integrals, so please do that. So this integral is going to be 1/3 x cubed minus, it'll be 2x squared over 2. I'm just going to make that x squared. And I'm going to evaluate between 0 and 2. So then again, hopefully we recall that this just means we plug in our top number. So when you plug in 2, you'll get 8/3 minus 4 minus, and then our bottom bound gets us 0 minus 0. And so really all I have is the first thing here, 8/3 minus 12/3, which ends up getting me an answer of -4/3. And I'm not going to put a box around that because I want to come back up here and talk about that. So the question is that the answer to the question? Right? And at this point you guys start to remember something. Hopefully you start to remember, yeah, I remember that when the region is below the x-axis, it's negative. And what I really want to focus there on, what is the it that you're talking about? Right? And the key is that it isn't the area. Right? Areas are never negative. Because this region was below the x-axis, this integral will respond, will give you a negative answer. But that doesn't mean that that area is negative, right? So given that the question actually asked, find the area of the region, it means, hey, good job, you did the integral. You found out that the integral was -4/3. But what that means is that the area of the region that was under the x-axis is +4/3. So it basically just means make sure that you're answering your questions carefully. If a question asks you, hey, what's the value of the integral, it may very well be negative because the region was under the axis. If the question says, hey, what's the area, areas are never negative, which means your area is going to be positive. You're going to get 4/3. So that's all I have for this review video. We've got 1 or 2 more left today about kind of moving things along in the difficulty curve. So I'll see you in those videos.